Okay guys, this is the next part of chapter 9.3. It's not as long as the last one. So this time we're going to evaluate trig functions given a point that is not on the unit circle. So this, if you notice guys, this is, if this point is at, I've gone around here, it's still a circle, but it's not the unit circle. So it's not going to have all the coordinates of the unit circle like root 2 over 2, root 3 over 2, that kind of thing. What we want to do here is we want to draw ourselves a little triangle. This is not particularly pretty. And remember what I said about this big angle theta? I can use this small angle inside and I get the exact same values that I would get using the big angle. So what I'm going to do is I'm going to take that triangle, I'm going to make it a little bigger so that it's not so incredibly hard to see. Okay, so this is going to be our theta right here. And we know they told us here that this point is at 1, -2. So if this is our origin right here, right? Let's see what x and y would be right here. Well, if I've gone over positive 1, we know this is 90, right? Gone over positive 1, and I've gone down -2. Now, unfortunately, this isn't one of our special right triangles, so the only way to find this third side is to use the Pythagorean theorem. So I call this B, this A, and this C. So we know that -2 squared plus 1 squared is equal to C squared, right? So that's 4 plus 1 equals C squared, and 5 equals C squared, right? And to undo a square, we're going to square root. So the square root of 5 is C. Now C is always going to be positive. So there's our triangle right here, right? So we've got A, B, and C. So if they want us to evaluate the 6 trig functions, we're going to use SOHCAHTOA. Okay, so we know that the sine of this angle theta is equal to the opposite over the hypotenuse, right? So let's look at the opposite. Here's our theta. Opposite over hypotenuse is -2 over the square root of 5, right? And then of course we have to rationalize the denominator, so I get -2 root 5 over 5. Notice I'm not using what we did last time. I'm not using the x-coordinate, the y-coordinate like we did last time. And that's because this is not the unit circle. This is a circle with a radius of root 5. The unit circle has a radius of 1. So we're back to SOHCAHTOA land for this. Okay, the cosine of theta is the adjacent over the hypotenuse. So notice we can still find sine trig functions, we just can't use our unit circle here. Okay, adjacent over hypotenuse is 1 over root 5. So 1 over root 5, if I rationalize the denominator, is root 5 over 5. Okay, and our tangent is equal to opposite over adjacent. Okay, opposite, -2, adjacent, 1. Okay, now we're doing the reciprocal trig functions. Cosecant, I'm going to flip over sine. So it's hypotenuse over opposite. So in that case, it's going to be square root of 5 over -2, which is just negative square root of 5 over 2, right? We don't have to worry about the denominator there because it doesn't have a square root. Secant is cosine flipped upside down. So I'm going to do hypotenuse over adjacent. If I do hypotenuse over adjacent, I get the square root of 5 over 1, which is the square root of 5. And then last but not least, the cotangent is equal to the adjacent over the opposite, which in this case is 1 over negative 2, which is negative 1/2. Now notice, guys, there's one right below that says you try. The notes are posted, so I'm going to, the blank one and the filled in one, so I'm going to let you guys work through that example. So we're going to turn the paper over and we are going to talk about reference angles. Okay, reference angles. We've kind of been insinuating, I've been kind of using the concept of a reference angle, but I haven't actually defined it yet. So it says here, draw the angles below and then find the reference angle. Draw angles below and find the reference angle. Well, it would definitely help if we knew what a reference angle was, right? So it says here, what is a reference angle? Well, here's what a reference angle is, guys. It is the angle that is formed between the terminal side, that's where we land on the unit circle, right, when we draw our angle, and the x-axis. Now, that may sound like mumbo jumbo right now until we see it in action. So let's look at the very first thing. It says, draw this angle, theta equals 5 pi over 3. So the first thing I want to do is I want to draw myself a set of coordinates. Okay, guys, where is 5 pi over 3? Well, the whole circle is 2 pi. Or another way of saying that is 6 pi over 3. Right? So if I'm going to go 5 pi over 3, right? That means I'm going to start here. Let me do it in red. And I'm going to go around here. And if the whole circle is 6 pi over 3, right? This whole thing out here is 5 pi over 3. How much is left here to get to 6 pi over 3? Well, just a single pi over 3, right? This here is the reference angle. The angle formed between the terminal side and the x-axis. So the reference angle here is pi over 3. Right, we've gone 5 pi over 3 around, and we've left a single leftover pi over 3 between our terminal side and the x-axis. Okay, let's try another one. Let's do, draw the angle negative 130 degrees. Okay, so if I want to draw the angle negative 130 degrees, let's draw our axis. Okay, negative 130 degrees means I'm going to head, starting at my starting point, and I'm going to head down. So let's see, this is 90, right? And then how much further do I have to go to get to? I have to go an extra 40, right? So now I've gone there. This is negative 130 degrees. Okay, guys, our reference angle is right here. That's our reference angle. So our reference angle is, what's the angle between where my terminal side landed and, oops, I don't need to do this, and the x-axis? Well, if this was 90 degrees, and then this was 40 degrees, do you see how I have 50 degrees left here to get to my x-axis? So my reference angle here is 50 degrees. Okay, so I'm gonna have to erase again. And we're only gonna do 2 more things, and then we're done. This one's a short one. Okay, so this next thing, what they want us to do is draw the angle. They want an extra little piece here. Draw the angle. Identify the reference angle. And then evaluate a trig function. So we're doing the same thing we did the last example, but we're going to take an extra step. So the first thing they want me to do here, tangent negative 240 degrees. Okay, so let's do it in the order that they say. Let's draw the angle. So I've got this, and I'm going negative 240. So let's head down. So if I go negative 240, let's head on down 90, right? 180. And how much more to 240? An extra 60. So this is 90, right? This is 90. And this is 60. Right? That's right, 180 plus, yeah. Okay, so how much is left here? Here, what we want to find, for our reference angle, we want to find the angle that is formed between the terminal side, which is here, and the x-axis. So our reference angle here, it's not this distance, because that's the y-axis. Our reference angle here is right there. So our reference angle is 60 degrees. Okay, guys, so where are we on the unit circle? We're at negative 240 degrees. So if I want to find, they want me to evaluate the tangent of negative 240. So I would rather evaluate something that's on the unit circle. So let's add 360. And that shows us that we can also evaluate the tangent of 120. That's the same thing as the tangent of negative 240. So let's go up to our unit circle, and let's find 120 degrees. 120 degrees, the coordinates are negative 1/2, comma, root 3 over 2. So negative 1/2, comma, root 3 over 2. And if you remember from the last time, tangent is equal to the y coordinate over the x coordinate. So it's root 3 over 2 over negative 1/2. And what does that reduce to but negative square root of 3? Right, so our reference angle, we drew our reference angle and evaluated the function. Okay, guys, this is our very last one, and this is the hardest one. We want cosecant of 17 pi over 6. Okay. Is that more than 1 revolution around the circle? Well, 1 revolution around the circle is equal to 2 pi. But let's think of that in terms of sixths. That would be 12 pi over 6. So what we have to do is we have to go 1 revolution around plus an extra 5 pi over 6. That's how we're going to draw our angle. So let's do it. We're going to go around the circle a whole time, right? And you guys, those of you who've turned the homework in, I've seen you do this very nicely. And then we're going to go an extra 5 pi over 6. So check out your unit circle. Well, if I go here, where am I going to land? Well, if I'm going to go an extra 5 pi over 6, if I go to pi, that would be 6 pi over 6. So I'm going to go an extra 5 pi over 6. Right? So this is 17 pi over 6. And here I've got an extra, I want an extra 5 pi over 6, which means this is pi over 6. Right, so our reference angle is pi over 6. Our reference angle is pi over 6. Now, again, 17 pi over 6 isn't on our unit circle, so what I suggest we do is subtract, right? We can find here, we've gone to 5 pi over 6, and that is on our unit circle. So to find the cosecant of 17 pi over 6, I'll just do this again. I can do 17 pi over 6 minus 2 pi, right? And that's going to get me 17 pi over 6 minus 12 pi over 6, and that's equal to 5 pi over 6. So let's find the tangent of 5 pi over 6. Let's go to our unit circle. Let's find 5 pi over 6. There it is. Coordinates are negative root 3 over 2 comma 1/2. So I get negative root 3 over 2 comma 1/2. And the tangent is equal to the y coordinate divided by the x coordinate. Okay, guys, we're almost done. That's equal to 1 over negative root 3, and I have to rationalize it. So it gives me negative root 3 over 3. That's the same thing as tangent 5 pi over 6 and cosecant 7 pi over 6. All right, guys, I'm anticipating some questions on this lesson, so please show up to my office hours. Bye.